How are we doing, folks? Something I omitted when we made our little test rig yesterday for testing coils, plug leads, plug caps, spark plugs, etc. We didn't do anything for the condenser, so we intend to have a look at that. And again, while I'm waiting for my paint just to harden before I give it a final flattening off. So I've removed the condenser or condenser pack from the bike, so just let's stick this on the stand and we'll have a quick run through. So I think 68 onwards, and obviously made by the Prince of Darkness, Mr. Lucas. So if you pull the rubber cover off, there's our two condensers, obviously unusually mounted quite differently. So it looks like these tabs or these Lucar connectors are soldered on the body, and the actual bit where the fly lead would normally be would go onto the frame. So can obviously do a triple, so you can get 3 in there because there's the center socket for it as well. So Rocket 3, Trident, obviously anything 68 onwards. I don't know, Tiger 90, they didn't make it then, didn't they? But T100, T120, T140, T150, yeah. So that's the little unit. So it's located at the top of the front down tube, and it's mounted on this bracket, which is mounted onto another bracket which goes onto the frame. So if you've had the frame powder coated or whatever, you've got a lot of connections to make sure that you've got a good return path through the frame. So that would be one of the first things I'd be making sure. I'd be scraping the paint, the powder coating off, making sure I've got a good flow back through the frame. But yeah, nice little unit, and I've got some information. Oh, it must be correct because I got it off the internet. Joke. No, I got it off a data sheet. So the Lucas part number for the condenser, just the condenser. There's even a part number for the metal frame and everything, but we're not interested in that. Part number just for the condenser on its own, Lucas part number 54420-128. Value rating 0.22 to 0.25 micro-farads UF, or in real money, because you should be looking at whole figures, 220 to 250 nano-farads. And there is a voltage given for it as well. 450, 500 volts is the tolerance. Obviously no current, just the voltage, because obviously you just blow it up or melt it. So we can test it. I've got a couple of meters here. Seem to get a different reading. I mean, these are good quality meters. This is my favourite little tool at the moment, this bad boy. So we'll use this guy for measuring the capacitance. So let's have him on. Excuse me. So we want, can we zoom you without getting a reflection? Maybe. Let's try it. Oh, now it's zooming on its own. Stop. Zoom back. Zoom back. Zoom, 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 zoom. There we go. Right. Let's pick what we want. Multimeter. And there's our symbol for capacitance. So we want to pick that. So it isn't polarized, it doesn't matter which way around we go. So I'm just going to go Just zoom you out a tad and down a tad so you can see what's going on. Let's pull the shield off. So I'm just going between the earth point and the body, if you like, and there it's 210 nano-farads, or 0.21 micro-farads is one, and the other one can stay on there kind of with that, and the other one is 200 and we've gone off 234. Not getting a good connection. 234, come on, stay. 234 nano-farads, or 0.234 micro-farads. So they're within the range, I would say. So what we'll do is, I'm not going to use this meter for the next test because it goes to 4 decimal places and it takes ages counting up and counting down. We're going to use the trusty old fluke for that. So just let me switch you off while we just set you up on this other meter. Back in a sec. Okay, we're on our trusty fluke. I've tilted it, trying to get rid of the glare a bit. Might be okay. So I'm going to just hook one of the leads up on the earth anyway, on the return path, or whatever you want to call it. And I'm also going to hook another fly lead up, not connected to anything, just to itself, also on the back, because what we need to do is, before we carry out any tests, we need to make sure they're discharged. So I'm just discharging anything that's in there, because the capacitor condenser is a storage device, so you can put energy into it, you can take energy out of it. So let's now go to the ohms on here, and when you set the meter to ohms, obviously we're open circuit at the moment because it's not touching anything. I think it pushes about 1 volt out to measure the resistance of things. So that 1 volt now is going to charge this capacitor. So on we go. So you'll see the voltage rise up, and then no more electrons are flowing. We've now charged it by taking some electrical energy from the ohms meter setting. So if now I take this off and now switch to DC volts, we'll now be able to measure the voltage stored, but obviously this will decay the voltage through the meter, so the voltage should drop down. So here we go, and there so it was over 1 volt, dropping down 0.2, 0.1 of a volt, and it'll drop down to nothing, obviously, just take a time. Or it might not drop down completely, but there, that's close enough for us. It might go. Okay, not got enough time in my life. So let's do the other one, the other side. So again, make sure it's fully discharged. Let's go to ohms. Give us a 1 volt charge, so we'll see it rise and then go open circuit when the electrons stop flowing. Off we go, counting down. So no more. So that's now fully charged with our 1 volt or whatever it was. So now we can switch to DC volts, and we can see that 1 volt decay to nothing. So it's still holding a charge. On we go. Dropping. And we're not going to go down to nothing because I've not got enough time in my life. So there we are. So that's a subtle test. So we measured the value of the nano-farads, and we've measured that it takes a charge, keeps it, and discharges when we ask it to discharge. There is another test now we're going to look at, which is a lot more brutal. It's not it is a non-destructive test, but if there's any weaknesses, they'll certainly be shown. So let me just set up for that, and we'll be back in a second. Okay, so what we've got now is my trusty old Mega, which is probably older than me now. Nothing's older than me. So this is capable of pushing out, if you're brave enough to hold these and turn the handle. Oh yes, I can feel a tingle. This is capable of pushing out 500 volts DC. So what we can do is we can charge up these, because according to the sheet it says that the voltage tolerance is 450-500 volts. So let's go for it. So I've put the other lead on, the discharge lead, and I've got the Mega lead on. Are they going to stay for us? Get that one out of the way a bit, because I want to be able to show the discharge on this, don't I? Like that. Right, let's give it some. So do that one first. So I'm going to give it plenty and take it off while I'm generating, because if I stop it'll run back into the meter through the coils, and see if we get a spark. Oh yes. So do that one more time. So that's up to the maximum voltage tolerance. Off. So leave it for a few seconds to make sure it's not discharging, and will it whack? Yes. Let's try the other one. Absolutely. And obviously before, if you've done that, discharge them before you touch them, because obviously we've got 500 volts stored in there. There's no current, so it can't do anything, can't stop your heart or anything, but if you've got a pacemaker you might blow your circuitry up, so be careful. Sorry, a bit of an interrupt there, sorry about that. So yeah, so make sure all your connections are good, because this bolts onto another bracket that then bolts onto the frame, and if you've had your frame powder coated, whatever, you know, you've got a lot of physical connections to make sure you've got that good earth path. And the condenser is important for a couple of reasons. While the points are open, it's still allowing a bit of electron flow, because it's obviously always connected to ground. So when the points do close and then open, it reduces the arc on the contact breakers, stops them burning away. But also when the points do open, this back feeds with a big EMF back, and it helps so the primary windings are going to collapse very quickly, but it obviously will force the secondary windings to collapse a lot quicker, and the faster that they collapse, then the greater the spark. So it's an important bit of kit, and yeah, sorry, forgot to include it in our tests with all this stuff yesterday. But anyway, there we go. Take it easy, folks, and we will catch you on the next one.